Okay, this video is about PySpark, and here we're going to talk about aggregation functions, special condition functions, special aggregations, and we will touch a bit window functions, but I will dedicate the next video after this one to Windows functions specifically. We will briefly touch some of them in this video though. Okay, this is a data set we're dealing with some kind of sales. These last two are calculated fields. These previous two are string fields, and void date is a date time field. So we have stock code, we have quantity sold per this invoice line, we have unit price, we have revenue by multiplying these two, and we have date. So there is no separate invoice line here. We have invoice no, and these are all invoice lines of that invoice. Okay, exercise 1. Count rows where quantity is above 10 per stock code. It implies that we should first aggregate by quantity. This is a global aggregation where I'm summing the quantity. This is equivalent SQL code. Some quantity grouped by stop code, and then we do conditional count. We count those quantity which are greater than 10, and basically we count the amount of rows where this condition is met per stock code. So this is the amount of stock codes which have been sold. This is a number of invoices where certain stock code has been sold in the quantity more than 10. If two stock codes have been sold in a quantity more than 10 in one invoice, it counts as 2. So this basically is a conditional count, and in Spark it goes as count if this condition is met. So both syntaxes, Spark syntax as count if, and Spark SQL syntax count case then quantity then one produce the same result. So wherever quantity in invoice of a certain stock code is above 10, we count it as 1. Okay, get first unit price per stock code. Use the first function. Okay, we do group by stock code, and we aggregate as first. So first is basically aggregation function and selects the first from the list. No ordering specified, so it's up to engine to determine which is first. I believe the first would be the first in sequence as records come in. This is the same for last group by stock code, last unit price. Okay, this is the same for first, but we add ignoring nulls. So it finds first customer ID, but ignoring nulls. So in this case, we might have catched up nulls, but here we don't catch nulls. Here's the same for the last with ignoring nulls. I checked if there are some is null cases, and there are some null cases. Means this means that no value was found at all. So either there are, so all the values for this stock code are null. No customer, the stock code was purchased, but the customer specified was null in all cases. Okay, coalesce customer ID with 0 for nulls per stock code. So basically we need to find first customer ID, but where no customer ID was found, we should coalesce it to null. So group by coalesce first as coalesce customer. This is the normal output. Here there is a condition for 0. So there are instances where coalesce customer is null. We actually can check if this customer, no, there is a different order, but this is basically the same case. This should be equivalent to this. Okay, count distinct invoice no approximate per stock code. This is approximate distinct count, which apparently goes faster. I have compared it with precise count distinct, and as you can see, we have minor differences. So the approximate works faster but produces approximate results. Here is them again side by side. Here is the condition where two do not match. Basically, they never match on these 10 rows. Exercise 8. Compute 50th percentile of quantity per stock code. Use percentile approx. So we're counting approximate percentile of quantity. Basically, this means how much quantity comprises 50%. So this is per stock code. This is median quantity, which is 50% quantity, and this is count of quantity. This is count of rows. So as we can see, sometimes this quantity is negative, which I believe means returns. Okay, here in this case, median quantity is comprises half of the total quantity. Okay, I have run this example in a more clean way. I have eliminated rows where quantity is negative, no returns basically. So, and calculated on those rows where quantity is positive. Still, you know, median quantity can be half, or it can be significantly less than a half in some cases. And it depends on the situation. Okay, anyway, this is not the point for us right now. Histogram of quantity per stock code with 5 bins. So we are creating 5 bins histogram. I filtered quantity above 0 here to avoid these negative values, and this is histogram numeric, and here we see the results. So 5 buckets for each stock code. If there are less values, we have less buckets. Okay, here is this is the detailed data for this stock code. You see 1 1 3 1 4 3. So we have quantity 4 3 times. So this is 4, and we have it 3 times. We have quantity 3 1 time, and we have quantity 1 1 time. So this is histogram of 3 distinct values. So no 5 buckets, only 3 buckets for this specific stock code. Exercise 10. Mode of unit price per stock code. So mode is a special function, and it indicates most frequently occurring value. So in this case, 1 2 2 3, the mode is 2. In this case, 5 5 5 7 8, mode is 5. In this case, 10 20 20 30 30, two mods, 20 and 30. So basically, mod is an aggregation function run on aggregated group of values, and these were the results of the mod. Sum of distinct unit price per stock code. Use sum distinct. Basically, nothing to it. Aggregation function, sum distinct. This is count distinct to compare, and this is normal sum. So the question is, what is distinct sum? Or sum distinct? What is sum distinct? So let's check on this stock code. You see, there are 4 rows for this stock code, and all unit prices in them is 7.95, and the sum distinct is 7.95. So it collected distinct values, which is the only value, 7.95, and it summed of them. Whereas sum price summed all 4, and it's 31.8. And there is one distinct value in this case. Okay, let's now check on another invoice number. This is it has 4 rows but 3 distinct values. Sum distinct is less than total sum. Let's see how we counter it. So there are, 3 distinct values here, and it summed 9.95 one time, and it counted 2.95 one time, and it summed 0 one time. Thus, we have 3 distinct values, but the distinct sum is less than total sum. It's less by this one value. Okay, so sum distinct basically sums unique values. It runs distinct on the variable which is inside sum. So basically, sum distinct means that you first run distinct on this field, and then you run sum on top of that distinct. Okay, collect all unit price values into array per stock code. Use array aggregate. This we have done above, and this is we simply collect into array. We had collect list, we had collect set above. Here we also collected array. This is array data type as a result. Count of non-null customer ID and grouping ID. Example using grouping ID. Okay, here we should do a special, aggregation. And this special aggregation is called cube. So we are making not just group by, but in SQL it tantamounts to group by cube construction. This is how cube construct looks like, in case you don't know. So group by cube, and what this does mean, it groups by this combination only country, this combination only country code, and groups globally. And this is global grouping. You see group ID 3, where country and stock code is null, and it should be group for the whole thing. And this is grouping for stock codes, and this way we have null here is grouping for country. So let's return to Spark example. So we have joined data frame 3 on allowed data frame, which is these 2 countries and 4 stock codes. and we grouped them on cube, and then we have counted, which is aggregation function, and then we displayed grouping. So grouping has basically three distinct values. 0 means grouping on both, 1 means grouping on the first one, 2 means grouping on a second one, I believe this is a bit mask, and 3 is grouping on both. So if we're grouping by 3 values, I'm not sure, but I might have done it below. Then we will have values from 0 to 7. Okay, let's see what we've got. So we have unfiltered results give all combinations 0, 1, 2, 3. Grouping number 1 is grouping by countries. Grouping number 2, second bit set, is grouping by stock code, and grouping ID 3, 2-bit set, is a global grouping by both fields. So this is equivalent code in SQL. So we have count, we have 2 aggregation fields, and we have grouping ID of both of them. So in grouping ID we supply 2 fields basically, and here we didn't supply any field, but here we supply both fields used in group by, and these are groupings, and the result is the same. Okay, next thing, yes, this is grouping by 3 fields. Yes, right next to it I have done my own test of grouping by 3 fields. So we have country, we have stock code, and we have year month, and we have grouped by all 3. So this is Spark frame that grouped by 3 of them. This is a join. I first filter the original data set by this section of combinations of these 3 fields. Then we run count, and here in this example I have specified fields to grouping ID. Basically no specification means all 3 are listed as we see. Okay, I have printed grouping ID, and I have created grouping ID in a bit format. So this has been called, not important how I did it, but I have made it into binary form. And order by ascending nulls last. I suppose this can be specified in Spark order by a clause. So what we've got? So null means grouping by all fields, global grouping, and 0 means that we grouped into all 3 specific fields. 1 means that we grouped by specific country and specific stock code. 2 means that we grouped by certain country and a certain month, and so on. Basically, we see all permutations of these combinations: country, stock code, year, month. The only thing, if some combination doesn't exist, it won't appear here. Apparently 6 exists, 5, 4, 3, 2, 1. So all combinations are present in this example. So we have basically invoice months combination, invoice another month combination, and we have a different calculation of non-null customers for each. So this is what is called group by cube. It's somewhat similar to ROLLUP cube, where all these aggregates are counted. ROLLUP. ROLLUP is a also special type of aggregation, but it does not tantamount to the cube. Basically, we list 3 fields in a certain sequence, but it, you see, it doesn't provide all the combinations. You see it, how to explain it. So it groups globally, it groups by country. You see, this is grouping by country. It groups by country plus stock code. This is country plus stock code. And it groups by all 3, country, stock code, year, month. This is by all 3. But it doesn't group by, for example, stock code plus year, month. You see, here in cube we have seen this combination. It's number 4. So country is omitted, but 2 others are present. But we don't see 4 here. So it goes basically forward. All 3, 2, except 2 first, 1 first, and no fields global group goodbye. We will see another example here called grouping sets. As far as I understood, grouping sets are not supported by, or maybe supported. Okay, I will admit that. So this is equivalent ROLLUP expression made using grouping sets. So basically we have this group by, this group by, this group by, this group by, and this group by, and they all combine together. This is the query equivalent to this one. So it's ROLLUP, which is equivalent group by grouping sets, this one, and the rest of the query is the same, and the result is the same. Okay, let's go on. Count non-null customer ID using NVL. Replace nulls with 0 first. Basically, this is expression of COALESCE which we have done above. But we counting null values as 0, thus they are not ignored by count. So basically this means that no user is considered as specific user number 0, and we count it as a distinct non-present user. Conditional sum, quantity only when unit price above 5. So this is not a big deal. It's a it's when you sum using condition inside aggregate function. So we place when otherwise statement inside. Here is when otherwise 0 example, and here is just when without otherwise 0, just to check what we've got. And here is yet another example where with sum and we do NVL to 0 in the end. So basically the sums are the same, but where no values exist, so values are null, first one gives 0 because it has otherwise 0. Second one might get null because no value, so it provides a sum of nulls is null, and this is 0. Okay, no cases were found where this value and this value were different. First value of unit price over a window by stock code ordered by invoice date. So this is the first example of window function. So we are taking first value of unit price, but we are paying attention to how we do order and how we partition. So this is window partitioned by stock code ordered by invoice date. And this is window function, first val price. And here is what we've got. This is default selection, and you know, these are sales of a certain stock code, and first value is the same, though it might be different in the next rows. Okay, this is a more detailed analysis of what we've got. So it's basically there is a total count of stock codes. There is a minimum unit price, maximum unit price, and I am filtering those where the total amount of rows is 5 and where minimum and maximum values are not the same. So let's check in detail what we've got. So we have first unit price 12, and yes, first unit price 12, and this is the order of invoice dates. So invoice dates go in increasing order. The total amount of 5, minimum unit price per stock code is 0, that's correct, and maximum stock price is 0. Okay, let's check something else, this example. So we have 5 rows, unit price changed, we have minimum of 125 and maximum of 7.62, and first value is 7.62. So it's tantamount to maximum, but it's not necessarily the maximum. Fortunately, in all these examples, the first value is tantamount to maximum, which is not necessarily the case in general. Okay, let's go on. Last value of unit price over a window ordered by invoice date. Okay, this is the same example, but with last price. I'm paying attention that a window here is specified as rows between current row and unbounded following. Let's check if we've got it right. So yes, we've got it right. Last is 0. Here, last is 0, and here is last is 125, and here is last is 0. Now, this is the wrong example. What's wrong? I didn't specify the rows between clause. And what we've got, you see, the last value is not 0, it's 0.12. This is why it is important to specify this clause. See, it's all about this clause. On last value functions, the same works with ranks ahead of your current position and lags leads ahead of your current position. You should specify this clause. It might be important. You see, because this is a wrong example, it doesn't catch the last value properly. See, it only checks the rows in between up to the current position. See, it's in here actually. As soon as we reach 335, we got 335. As soon as we reach 1.25, we got 1.25. But we don't reach the correct value here on the line number 3. Okay, but we do reach it here when we specified rows between. Okay, count rows per stock code using count. Okay, this is simple. This is stock code, count asterisk alias total rows, nothing to reach. Count of rows. Okay, approximate percentile for unit price. So this is percentile approximate sort of histogram where percents accounted for values of this percentile. So we have first bucket which should accumulate 25%. We have second bucket which should accumulate between 25 and 50%, and so on. And here we got these buckets. Some buckets might not be filled if there are not many values, but where the amount of values is above 5, the buckets are filled. And these might be, you know, the same, but they are filled. So the buckets, as they go from left to right, have their values increased. So they are either the same or it increases from bucket to bucket. Collect distinct customer ID per stock code into array. Okay, this is collect set, which we have seen. There is nothing to read by now. Group by stock code, collect set. This is the set of values collected. The set might be empty actually. Okay, this was enough for this video and for this exercise. In the next exercise, we are going to tackle Windows functions finally in detail, in more detailed way. Aggregate window functions, lead logs, ranks, and so on.